Hey everyone and welcome back. Imagine you are writing your very first Java program. You write int age is equal to 27. Immediately Java shows a compilation error. Why? The value clearly exists, the variable clearly exists, so why won't Java allow it? The answer lies in one of the most fundamental concepts in Java, data types. In today's lesson, we will understand not only what data types are, but why Java needs them, how they work internally, and how to choose the right one in real applications. Imagine you are working at a bank. One customer walks in and wants to deposit rupees 50,000. Another customer wants to update his name. A third customer wants to enable or disable SMS alerts. Now imagine the bank employee tries to write all three pieces of information into exactly the same box: the amount, the customer's name, and the answer yes or no. Would the bank system still work correctly? Of course not. Money is inherently different from a name. A name is completely different from a yes or no value. Each type of information needs its own proper dedicated place. Programming languages face exactly the same challenge. Whenever we write a Java program, we are constantly working with different kinds of information: a student's age, a student's name, a student's percentage, a student's letter grade, whether the student passed or failed. Although all of these are called data, they are not the same kind of data. Some are numbers, some contain decimal values, some contain only a single character. Others can have only two possible values, true or false. By the end of this tutorial, you will understand not only what data types are, but exactly why Java has so many of them, when to use each one, and why choosing the correct data type makes your programs blazing fast, efficient, and reliable. Let's begin. Before understanding data types, let's quickly define data. Data simply means information. Every single program we write works with information. Think about the apps you use every day. WhatsApp stores text messages, Amazon stores product prices, Google Maps stores geographic coordinates, Netflix stores movie titles, college management system stores student records. Different applications store different kinds of information, but they all have one thing in common: they process data. Whether you are building a banking application, an e commerce website, or a game, your program is constantly working with data. Let's look at some everyday examples: your name, your age, your salary, your phone number, your email address, your graduation percentage, your blood group, or whether you are eligible to vote. All of these are examples of data. Now, here is the interesting question: if all of these are just data, why doesn't Java just store everything in the exact same way? Think about filling out a simple application form. Can you write your name inside the age field? No. Can you write 95.5 inside the citizenship field? Again, no. Each field expects a particular kind of information. Java works exactly the same way. A variable cannot simply store anything. Every variable is designed to hold a specific kind of value. A data type tells Java what kind of value can be stored in a variable, how much memory should be allocated, and what operations are allowed on that value. This brings us to one of my favorite beginner questions. If computers ultimately understand everything as binary, just zeros and ones, why does Java give us so many different data types? Why not just have one single type called universal data and be done with it? The short answer is memory optimization. Imagine storing a tiny ring inside a huge shipping container. It would work, but most of the space would be wasted. Computers face the same problem. Small values don't need large amounts of memory, while very large values need enough space to be stored safely. Java provides different data types so that small values don't occupy unnecessarily large amounts of space, while large values still have enough room to be stored safely. This is why Java is considered both highly efficient and type safe. Now that we understand why data types exist, let's see how Java organizes them. Java classifies all data types into two broad categories: primitive data types and non-primitive data types. Let's begin with primitive data types. The word primitive means basic or built-in. Primitive data types are the predefined data types provided by Java. Unlike objects, they store actual values directly in memory. For example, int employee ID is equal to 27. Here, employee ID is the variable, int is the primitive data type, and 27 is the value. Instead of storing reference to an object, Java stores the value 27 directly. Java provides 8 primitive data types that cover the most common kinds of simple values used in programming. Byte, short, int, and long are used for numbers without decimal points like 10, 25, or minus 500. Float and double are used for fractional values like 3.14 or 95.5. Char is used for a single character or symbol like A or rupees. Boolean is used for true or false values. Now, what about non-primitive data types? Real world data is complex. Imagine building a student management system. A student is not just an age or a name. A student is a collection of an age, a name, a percentage, and an ID all combined. To represent these complex real world entities, Java uses non primitive data types, often called reference types. These include string, arrays, classes, object, interfaces, and enums. For example, we use string all the time to store text. Example, string name is equal to techie. Notice that string starts with a capital S. That is because it is not a primitive type. It is actually a class. We will learn non-primitive types in detail later. For now, simply remember this. Primitive data types represent simple values such as numbers, characters, and Boolean values. Non-primitive data types represent more complex data such as text, arrays, and objects. Primitive data types have fixed size, whereas the size of non-primitive data depends on the kind of object being represented. For now, keep this core contrast in mind. Before we move on, let me answer a question many beginners have. You may have seen code like this, where total employees is equal to 7,700. Is where another data type? No. Where is not a data type. Java still assigns a proper data type such as int, double, or string. The compiler simply figures out the type automatically based on the value you assign. We will learn everything about where, how it works, and when you should or shouldn't use it in a separate tutorial. For this tutorial, we will focus only on the actual data types provided by Java. Before we discuss each data type, let's quickly understand how computer memory is measured. The smallest unit of memory is called a bit. A bit can store only one of two values, 0 or 1. 8 bits together form 1 byte. So, 1 byte is equal to 8 bits, 2 byte is equal to 16 bits, 4 bytes is equal to 32 bits, 8 bytes is equal to 64 bits, and so on. Since every primitive data occupies a fixed number of bytes, understanding bits and bytes helps us understand why different data types have different ranges. Now let's look at each integer data type one by one. We will begin with the four integer data types byte, short, int, and long, and understand their memory sizes, ranges, and real world use cases. As the name suggests, integer data types are used to store whole numbers, meaning numbers without any decimal point. Examples include 17,000, 0, or minus 77. The smallest integer data type in Java is byte. It occupies just 1 byte or 8 bits of memory. Its range is from minus 128 to 127 and default value is 0. Now here is an interesting question. Why is the range exactly minus 128 to 127? Why not minus 100 to 100 or minus 170 to 170? Let's understand why. Since a byte contains 8 bits, it can create 2 raised to the power of 8, that is 256 different combinations. Java uses a representation called 2's complement to store signed integers. Don't worry if that sounds unfamiliar. We will study it in detail in a later tutorial. For now, let's see how it determines the range mathematically. The range for any signed integer data type can be calculated using this formula. Minus 2 raised to the power of n minus 1 to 2 raised to the power of n minus 1 minus, where n represents the number of bits used by that data type. For a byte, n is equal to 8. So, the range becomes minus 2 raised to the power of 8 minus 1, that is 7, to 2 raised to the power of 8 minus 1, that is 7, minus 1, which evaluates to minus 128 to 127. You don't need to memorize this formula for day-to-day programming, but it's a common interview topic. Understanding where these ranges come from is much more valuable than simply memorizing them. You might notice that there are 128 negative values but only 127 positive values. That's because 2's complement represents 0 as neither positive nor negative, leaving one extra value on the negative side. Now let's see what happens if we exceed this range. Example, byte age is equal to 128. This results in a compile time error because 128 is outside the valid range of the byte data type. If we hover over the error in IntelliJ IDEA, the message says required type byte provided int. That's because integer literals in Java are treated as int by default. Since 128 is outside the valid range of byte, the compiler reports that it found an int value where a byte was expected. The IDE also suggests adding a cast expression. We will learn what type casting is and when it should be used in a later tutorial. Many beginners think since byte uses less memory, I should use it everywhere. Actually, that's not true. In most business applications, you will never use byte for storing values such as age, marks, or employee count. Instead, byte is commonly used while working with binary files, images, audio data, network communication, and file input-output operations. For most everyday Java applications, you will rarely choose byte as your integer data type. The next integer type is short. As the name suggests, it is larger than byte but smaller than int. Memory size is 2 bytes, that is 16 bits. Its range is minus 32,768 to 32,767. Its default value is 0. Example: short salary is equal to 25,000. Because short uses 16 bits, it can represent much larger numbers than byte. In modern Java development, short is used much less frequently than int. However, it is still useful when working with legacy systems interacting with hardware, memory sensitive applications. For normal business applications, developers usually skip short and directly use int. Now we come to the most important integer data type in Java, int. Memory size is 4 bytes, that is 32 bits. Range is around minus 2.14 billion to plus 2.14 billion, or mathematically minus 2 raised to the power of 31 to 2 raised to the power of 31 minus 1. Default value is 0. Example, int total employee count is equal to 65,000. Now here is something important. Whenever you write a whole number in Java, like this 7, 17 or 77, if you are storing a whole number and you are not sure what to use, choose int. Why do developers love it? First, its 2 billion range is more than enough for most normal counts like student IDs or total marks. Second, modern 32-bit and 64-bit computer processors are explicitly optimized to handle 32-bit integers efficiently at a hardware level. Using a smaller type like byte inside local calculations doesn't actually speed things up because the CPU handles them using 32-bit registers anyway. In most Java programs, int is the default choice for storing whole numbers. Sometimes even int is not large enough. Imagine storing the distance between planets, Earth's population, total number of website visits over many years, the number of stars in a galaxy, scientific calculations. These values can become extremely large. For such situations, Java provides long. A long occupies 8 bytes or 64 bits of memory. Its range is approximately minus 9.22 quintillion to plus 9.22 quintillion. Its default value is 0. For example, long distance to stars is equal to 987654321123456789L. Notice something interesting. The number ends with the letter L. Whenever you write a very large integer literal, adding L tells Java, treat this value as a long. Both uppercase L and lowercase l are valid suffixes in Java. However, Java developers almost always use uppercase L because lowercase l looks very similar to the digit 1, making the code harder to read. A common interview question is which integer data type should we use? Here is a simple guideline. Use int for most whole numbers. Use long when values may exceed the range of an int. Use byte mainly when working with binary data or memory sensitive applications. Use short only when you have a specific reason. If you are a beginner and don't know which one to choose, start with int. As you gain experience, you will naturally learn another type is more appropriate. So far, we have learned about the whole numbers, but not all numbers are whole numbers. What happens when you need to store a fraction like 77.7 or the value of pi? 3.1416. An int will instantly throw a compiler error. For such values, Java provides two more primitive data types, float and double. Both store decimal numbers. The main difference is precision. Precision refers to how many digits a data type can accurately represent, especially after the decimal point. Imagine you and a friend measuring a table. You state it's 2.7 meters. Your friend uses a highly precise digital instrument and records 2.737481 meters. Both are correct, but the second measurement has far higher precision. Similarly, Java provides one data type for ordinary decimal values and another for situations where greater precision is required. Let's begin with float. Memory size is 4 bytes. Approximate precision is 6 to 7 decimal digits. Default value is 0.0. Example, float price is equal to 77.7f. Notice the letter f at the end. When Java sees a decimal number like 77.7, it automatically treats it as a double. So if you want Java to store the value as a float, you must explicitly add the suffix small f or capital F. Today, float is mostly used in graphics programming, game development, and other memory sensitive applications where millions of decimal values are processed. In everyday Java application development, however, you will usually see developers choosing double instead. Let's see why. The next primitive data type is double. Memory size is 8 bytes. Approximate precision is 15 to 16 decimal digits. Default value is 0.0. Example, double pi is equal to 3.1416. Notice something? There is no suffix at the end. That's because Java automatically treats decimal literals as doubles. Why is it called double? The name comes from the fact that it provides double the storage of a float. A float occupies 4 bytes, a double occupies 8 bytes. More memory allows it to store decimal values with much greater precision. Which one should you use? This is one of the most common beginner questions. For most Java programs, the answer is simple. Use double. It is the default decimal type in Java and provides much higher precision. Use float only when you have a specific reason, such as reducing memory usage in applications that handle very large amounts of decimal data. While double is highly precise, both float and double suffer from subtle binary round of errors due to how fractional numbers are stored in base to binary format. For example, doing math like zero point 0.1 plus zero point 0.2 might result in this number. Notice 4 in the end. Therefore, never use float or double for exact financial applications like banking or currency calculations. In later tutorials, we will learn about a special Java class called Big Decimal, designed explicitly for handling money. Now let's move from numbers to characters. Suppose you want to store the grade obtained by a student. It might be A, B or C. Or perhaps you want to store the first letter of a person's name or a mathematical symbol or a punctuation mark. These are all single characters. For this purpose, Java provides char. A char stores exactly one single character and it must be enclosed in single quote. Memory size is 2 bytes, that is 16 bits. Default value is the Unicode null character. Example, char grade is equal to B. Older languages like C used 1 byte for characters because they relied solely on basic ASCII, which mainly covers English letters. Java uses 2 bytes because it adopts Unicode, allowing it to represent characters, symbols, and scripts from almost every language on earth. Did you know that a char is actually stored as an unsigned whole number under the hood? When you write char letter is equal to A, Java internally stores the Unicode value 65, which is the Unicode mapping for uppercase A. Now, let's discuss the final primitive data type. Imagine you are writing a program to determine, is the student present? Has the payment been completed? Is the user logged in? Can these questions have hundreds of different answers? No. Each question has only two possible answers, yes or no, true or false. For such situations, Java provides Boolean. Unlike numeric data types, a boolean does not store numbers. Default value is false. Example, boolean is logged in is equal to true. How much memory does boolean use? This is an interesting question. For byte, short, int, long, float, double, and char, Java specifies their sizes. However, for boolean, the Java language specification does not define a fixed memory size. The exact representation depends on the JVM implementation. For beginners, you don't need to worry about the internal representation. The important point is that a boolean can store only one of two logical values, true or false. You will use boolean everywhere in Java. For example, checking passwords, verifying login status, determining whether a student passed an exam, checking if a file exists, validating user input, and making decisions using if statements. Whenever your program needs to answer a yes or no question, boolean is usually the right choice. Let's look at the complete master snapshot of Java's primitive data types. If you ever feel confused about which primitive type to choose, remember these four simple rules. Use int for most whole numbers, use double for most decimal numbers, use char for a single character, use boolean for true or false. The remaining types byte, short, long, and float are mainly for specific situations where memory usage, value range, or compatibility matters. Now you know all 8 primitive data types, but before we finish this lesson, there are a few important concepts every Java beginner should understand. We will answer questions like what are default values and when they are actually assigned, what common mistakes do beginners make with data types, how can you decide which data type to choose in real programs. Finally, we will wrap up with a quick recap, a question for you. and a preview of our next tutorial, where we will take a deep dive into Java variables. What exactly is a default value? Let's understand. Imagine moving into a new apartment. Before you place any furniture inside, the rooms already exist. Similarly, when Java creates an object, memory is allocated first, and its instance variables automatically receive predefined values. These predefined values are called default values. Integer types are initialized to 0, floating point types to zero point 0, boolean to false, and char to Unicode null. These default values apply to instance variables and static variables, not local variables inside methods. Local variables must be initialized before you use them. If you create a variable inside your main method and try to print it without initializing it first, your code will fail to compile with a red error saying variable might not have been initialized. We will deep dive into why this happens in our next tutorials on variables. Let's look at a few mistakes beginners often make. If you avoid this, you will save yourself a lot of debugging time. Mistake 1 is using int for decimal values. If you write int percentage is equal to 95.5, you will get a compiler error saying required type int provided double because int stores only whole numbers. Use double percentage is equal to 95.5 instead. Mistake 2 is forgetting the L suffix for large long literals. If you write long distance is equal to, you will get a compiler error saying integer number too large. Add L for long literals. Mistake 3 is forgetting the F suffix for float literals. If you write float price is equal to 99.99, you will get a compiler error saying required type float provided double. Add F for float literals. Mistake 4 is code confusion. If you write char grade is equal to A, you will get a compiler error saying required type char provided string. Double quotes are exclusively reserved for string objects, even if it's just one letter. A char must use single quotes. Mistake 5 is premature optimization. Don't use byte or short everywhere just because you think it makes your basic app faster. Modern systems want int and double. Prioritize code readability and standard conventions unless you are writing high performance systems. If an interviewer asks you, why does Java provide multiple primitive data types instead of just one? Give this concise professional answer. Java provides multiple primitive data types so that different kinds of information can be stored efficiently. Smaller values don't waste memory, larger values have enough range, decimal values retain the required precision, characters are represented correctly using Unicode, and logical values are stored as true or false. Understanding the reasoning is more valuable than memorizing the list. We covered a massive amount of ground today. Let's do a quick recap. We learned what data is, why Java separates data into precise data types to protect your system memory, the core architectural differences between primitive and non-primitive types, and we walked step by step through all 8 primitive types, their formulas, and their default behaviors. Before we close out today's lesson, I have a quick challenge for you to test your skills. Drop a comment below telling me which specific Java data types you would use to store these 4 pieces of real-world application data: a student's age, a student's exact final exam percentage, a student's letter grade A, B or C, a checkbox showing whether the student has paid their fees, and more importantly, tell me why you choose each of those data types. Now that you confidently understand what kind of data Java can store, the next logical question is where and how is this data actually held and manipulated while our program runs. That is exactly what we are going to master in our next tutorial, Java variables in depth. If you found this breakdown helpful, please give this video a thumbs up. Don't forget to hit subscribe and turn on notifications so you don't miss the next deep dive. Thank you so much for watching. Keep learning, keep growing, and stay connected for more updates.